When thinking about the origin of the universe, what came before the Big Bang? And if there was no before, what was the cause of the Big Bang in the first place? Until a few centuries ago, the answer was easy. Some eternal deity set everything in motion. Even Isaac Newton believed that God created the universe some 6,000 years ago. Later, many scientists, including young Albert Einstein, assumed the universe itself to be eternal and everlasting. Of course, stars could be born and die in it, planets could collide, civilizations could arise and fall, but on large spatial scales and over long periods of time, it always looked roughly the same as it does now. Only in the 1930s did convincing evidence of the expansion of the universe appear, and in the 1960s, evidence of its origin in the Big Bang. Such a radical revolution in the scientific worldview has not occurred perhaps since the recognition of the heliocentric system. But then, two equally difficult questions arose. First, what actually was before the Big Bang? What was space like before it began to expand, and how long did it stay in this primordial state? And secondly, everything that has a beginning has an end, so what will be the end of our universe? The English physicist Brian Cox set out to find an answer to this question. Now, in a world-shattering revelation, physicist and professor of particle physics Brian Cox has just declared that he strongly suspected that the universe existed before the Big Bang, throwing the theory of our origins on its head. We used to think that the universe emerged in that state, very hot and very dense, at the beginning of time, and we used to call that the Big Bang. But now we strongly suspect that the universe existed before that, and in that sense, it's possible to speak of a time before the Big Bang. Join us as we dig deep into how Brian Cox just debunked the Big Bang. Professor Brian Cox has transformed his field of science in the 21st century into something accessible to everyone, regularly contributing to public debate and discussion. Never one to shy away from the big questions, the physicist previously took on the story of the Big Bang. The idea of the Big Bang first came about back in the 1920s and 1930s. When we looked out at distant galaxies, we discovered something peculiar. The farther away from us they were, the faster they appeared to be receding from us. According to the predictions of Einstein's general relativity, a static universe would be gravitationally unstable. Everything needed to either be moving away from one another or collapsing towards one another if the fabric of space obeyed his laws. The observation of this apparent recession taught us that the universe was expanding. Today, if things are getting farther apart as time goes on, it means they were closer together in the distant past. An expanding universe doesn't just mean that things get farther apart as time goes on. It also means that the light existing in the universe stretches in wavelength as we travel forward in time. Since wavelength determines energy, that means the universe cools as we age, and hence, things were hotter in the past. Extrapolate this back far enough, and you'll come to a time where everything was so hot that not even neutral atoms could form. If this picture were correct, we should see a leftover glow of radiation today in all directions that had cooled to just a few degrees above absolute zero. The discovery of this cosmic microwave background in 1964 by Arno Penzias and Bob Wilson was a breathtaking confirmation of the Big Bang. It's tempting, therefore, to keep extrapolating backwards in time to when the universe was even hotter, denser, and more compact. If you continue to go back, you'll find a time where it was too hot to form atomic nuclei, where the radiation was so hot that any bound protons and neutrons would be blasted apart. A time where matter and antimatter pairs could spontaneously form as the universe is so energetic that pairs of particles and antiparticles can spontaneously be created. A time where individual protons and neutrons break down into a quark-gluon plasma. This sets up a very different picture of the beginning of what led to a Big Bang, rather than the emergence of time and space from a singular state. Now we get to address the really big questions. What does all of this mean for the true beginning of the universe, if such a thing even existed? Well, the bottom line might be, the hot Big Bang definitely happened, but it doesn't extend to go all the way back to an arbitrarily hot and dense state. Instead, the very early universe underwent a period of time where all of the energy that would go into the matter and radiation present today was instead bound up in the fabric of space itself. That period, known as cosmic inflation, came to an end and gave rise to the hot Big Bang, but never created an arbitrarily hot dense state, nor did it create a singularity. What happened prior to inflation, or whether inflation was eternal to the past, is still an open question. But one thing is for certain, The Big Bang is not the beginning of the universe. But if the Big Bang wasn't the beginning, what was it? What happened before the Big Bang? Short answer, we don't know. Long answer, it could have been a lot of things, each mind-bending in its own way. It's possible that before the Big Bang, the universe was an infinite stretch of an ultra-hot dense material persisting in a steady state, until for some reason the Big Bang occurred. This extra-dense universe may have been governed by quantum mechanics, the physics of the extremely small scale. The Big Bang then would have represented the moment that classical physics took over as the major driver of the universe's evolution. For Stephen Hawking, this moment was all that mattered before the Big Bang. He said, "Events are unmeasurable and thus undefined." Hawking called this the no-boundary proposal, in which time and space are finite but don't have any boundaries or starting or ending points, the same way that the planet Earth is finite but has no edge. Or perhaps there was something else before the Big Bang that's worth pondering. A bold idea of Professor Brian Cox suggested there was a time before the Big Bang, a time in which the universe did not exist at all. He explored this in his documentary series Universe, stating that before the launch point of the Big Bang, there was no matter at all. All that existed was space-time and an ocean of energy, almost still but gently rippling. This place, as he said, should be imagined as a near ocean of energy filling the void. It would have had no structures, and the energy in the space would have caused it to stretch violently, something known in space as inflation. Flipping the Bible creation story on its head, Brian Cox proceeded to explain the science creation story. The crux of the story is an unimaginably violent expansion known as inflation, he said. In the beginning, there was an ocean of energy that drove a rapid expansion of space, known as inflation. There were ripples in the ocean. As inflation ended, the ocean of energy was converted into matter by the Big Bang, and the pattern of the ripples was imprinted into our universe as regions of slightly different density in the hydrogen and helium gas that formed shortly after the Big Bang. The denser regions of gas collapsed to form the first stars and the first galaxies, and 9 billion years later, a new star formed in the Milky Way, the Sun. The star was joined by 8 planets, including Earth, and nearly 13.8 billion years after it all began, we emerged blinking into the light. Notably, Brian Cox is not the only one to make such an argument about the beginning of the universe. Remarkable theoretical physics research has revealed a possible window into the very early universe, showing that it may be just the latest iteration of a bang-bounce cycle that has been going on for well at least once, and possibly forever. According to the study, the physics that we need to understand the early universe, a wonderfully complicated mishmash of general relativity and high-energy particle physics, can take us only so far before breaking down. As we try to push deeper into the first moments of our cosmos, the math gets harder and harder to solve, all the way to the point where it just quits. The main sign that we have terrain yet to be explored is the presence of a singularity or a point of infinite density at the beginning of the Big Bang. Taken at face value, this tells us that at one point, the universe was crammed into an infinitely tiny, infinitely dense point. This is obviously absurd, and what it really tells us is that we need new physics to solve this problem. Our current toolkit just isn't good enough to save the day. We need some new physics, something that is capable of handling gravity and the other forces combined at ultra-high energies, and that's exactly what string theory claims to be. If a model of physics that is capable of handling gravity and the other forces combined at ultra-high energies, which means that string theory claims it can explain the earliest moment of the universe, one of the earliest string theory notions is the ariotic universe, which comes from the Greek word for conflation or fire in this scenario. What we know as the Big Bang was sparked by something else happening before it. The Big Bang was not a beginning but one part of a larger process. Extending the ariotic concept has led to a theory again motivated by string theory called cyclic cosmology. Technically, the idea of the universe continually repeating itself is thousands of years old and predates physics, but string theory gave the idea firm mathematical grounding. The cyclic universe goes about exactly as you might imagine, continually bouncing between big bangs and big crunches, potentially for eternity back in time and for eternity into the future.